Graph the solution set of 1 minus 2x is less than 5 and express it in interval notation. Here we need to start by isolating x on one side of the inequality. What should we do first? In order to get x alone, we need to get this 2x term alone, so we need to get rid of the 1. So we'll want to subtract 1 from both sides of the inequality. When we subtract 1 on the left-hand side, we end up with negative 2x. And when we subtract 1 on the right-hand side, we're left with 4. At this point, we need to ask, do we need to flip the inequality symbol when we subtract 1 from both sides? And the answer is no, we do not flip the inequality sign when we're adding or subtracting on both sides. We only do that when we're multiplying or dividing both sides by a negative quantity. Therefore, we end up with negative 2x is less than 4. Now, what's the next step to getting x alone here? To get x alone in this inequality, we have to divide both sides by negative 2. When we do that, on the left-hand side, we're just left with x, and on the right-hand side, 4 divided by negative 2 is negative 2. At this point, do we need to flip the inequality symbol after we divided both sides by negative 2? Yes, whenever we divide both sides of an inequality by a negative number, we need to flip the inequality symbol. So in this case, we get x is greater than 2. And at this point, we have solved for x, so we're ready to graph the solution set. Here I've drawn a number line for us, but I need to ask, what should our graph look like? Since x is not allowed to be equal to negative 2, that tells us we'll have an open circle at negative 2. And since x is bigger than negative 2, that tells us we need to shade to the right, because that's where the numbers that are larger than negative 2 lie. So our graph consists of an open circle at negative 2 and then shaded to the right. Lastly, we need to express this in interval notation. What will our interval notation look like? Because we're graphing from negative 2 to infinity, we're going to have negative 2 comma infinity. Infinity will always have a parenthesis, and in this case, negative 2 will have a parenthesis because it's an open circle, which means that negative 2 is not in our solution set. So we've got parenthesis, negative 2, comma, infinity, closed parenthesis. Let's do one more. Graph the solution set of negative 3/2 is greater than or equal to y/5 plus 3/10 and express it in interval notation. Here we have an inequality with fractions in it. The very first thing we should do to simplify things is to multiply both sides by the least common denominator. What's the least common denominator in this inequality? Here, the least common denominator is 10, so we need to multiply both sides by 10 to get rid of the fractions. On the left, 10 times negative 3/2 is negative 15. On the right, we're going to have to distribute that 10 to both terms. 10 times y over 5 is 2y, and then 10 times 3/10 is 3. So we've got negative 15 on the left and 2y plus 3 on the right. Do we need to flip the inequality symbol here when we multiply both sides by 10? No. Since we multiplied both sides by a positive number, we keep the inequality symbol just as it is. If it was a negative number, then we would have had to flip it though. Now we have negative 15 is greater than or equal to 2y plus 3. We want to get the variable term by itself now, so we want to subtract 3 from both sides. What do we get when we subtract 3 from both sides of the inequality? On the left-hand side, when we subtract 3, negative 15 minus 3 is negative 18. On the right-hand side, the 3's cancel, just leaving us with the 2y. And the inequality sign is not going to flip because we've subtracted a quantity. When we're adding and subtracting, it doesn't flip. It only flips if we multiply or divide by a negative number. So here we have negative 18 is greater than or equal to 2y, and we're almost at the point where we have y by itself. What do we get in the final step here when we isolate y? To get y by itself, we need to divide both sides by 2, and when we do that, we get negative 9 on the left. We get y all by itself on the right, and again, we do not flip the inequality sign. We were dividing by a number, but it wasn't a negative number. So the inequality sign does not change. So we've got negative 9 is greater than or equal to y. At this point, there's one more thing we can do to make this easier to work with. We could flip the two sides of the inequality, since it's usually easier for our brains to process an inequality if the variable is on the left-hand side. If we do that, then we also have to flip the inequality sign. What would that give us? If we flip the two sides of this inequality, then y is on the left, negative 9 is on the right, and the inequality sign becomes less than or equal to. So now we have y is less than or equal to negative 9, and we're ready to graph this on the number line. We know we need negative 9 on the number line. I'm actually going to go by 3's here. Negative 3, negative 6, negative 9, negative 12, and then positive 3. Oftentimes when we've got larger numbers, even if it's large in the negative direction, instead of going by 1's, we might want to go by 2's or by 3's or 5's or something else. So we've got our number line drawn. What should our graph look like? Since y is allowed to be equal to negative 9, we'll have a closed circle on negative 9. And since it's also allowed to be less than negative 9, we want to shade to the left because that's where the numbers fall that are less than negative 9. So this is our graph. Finally, what will our interval notation look like? Since our shaded region goes all the way to the left towards negative infinity, and on the right it stops at negative 9, we'll have negative infinity comma negative 9. We'll have a parenthesis on the negative infinity like usual, and then for the negative 9, we'll use a bracket because it was allowed to be equal to negative 9, and so we use a bracket to denote that.